Hello, I'm Jack Drury.
Hi, I'm Sergio Alvarez.
And we are back with ADPSM, and we're going to be diving into a menu item called Operational Presets. So you're going to go into a huge amount of detail about this in a moment. Before we do, you're going to be talking about something called 4-channel wideband quite a lot in this video. Yeah. Sergio, what is 4-channel wideband?
4-channel wideband is basically our version of WMAS, right? So with Axient Digital PSM, a quad transmitter can use a single frequency to support 4 stereo audio channels.
Excellent. So that is going to have one frequency, which is 800 meg wide?
800 kilohertz wide.
800 kilohertz wide, right, okay.
And then for the dual, it is a 400 kilohertz carrier that supports 2 channels of stereo audio.
So one frequency, 4 sub-carriers for the quad,
Correct.
2 sub-carriers for the dual.
Correct.
And it's our version of WMAS where we are being more spectrally efficient with our frequencies.
Right. When you're using a single RF carrier for multiple users, you don't have as many carriers on air that are each producing its own intermodulation, right? So less frequencies to coordinate, which kind of makes things easier. And then it also cleans up the noise floor, right? When you have less RF carriers to coordinate, there's not as many intermods in the air, so it plays a lot nicer with your wireless mics, for example.
Makes sense. Okay, so from now on, if you hear us talking about 4-channel wideband, you know we're discussing our version of WMAS when it comes to Axient Digital PSM. And there are some other modes that you can use this system in.
Yes.
I think that's what I'm just going to throw to you to take us through this menu. First one we have is 4-channel wideband spatial diversity.
Right. So here you'll notice you have all your channels on a single frequency coming out of 2 spatial diversity RF outputs.
Excellent. So for our quad, it's channels 1 to 4 on A and D, and the dual, it's channels 1 to 2 on A and B.
Correct.
Excellent stuff. Let's go to the next one. We have is 4-channel wideband.
Right. So 4-channel wideband is same transmission mode, but you've disabled spatial diversity, right? Which is helpful. If there's some logistical reason why you can't have 2 antennas, that's okay. You can always turn that off. And so you'd have, again, all your channels on a single frequency coming out of a single antenna. In this case, it's A on both cases. Excellent. For the quad and the dual.
And you gain a bit of output power, is that right?
Correct. There's a bigger pool of transmitter compensation to pull from.
Understood. Okay, let's have a look at the next one. This is narrowband combined.
Yeah, so narrowband, which we talked about, you have a channel that has its own dedicated frequency, but the transmitter devices are able to combine that internally without the use of an external combiner. And then you could use an external combiner to combine that after the fact as well.
Okay, so this is more traditional to how we would have done stuff previously. It's a digital narrowband signal, but we're combining down to 1 BNC. So on the quad, it's channels 1 to 4 to A, and on the dual, it's channels 1 to 2 to A. If you wanted to do this on PSM 1000, you'd have had to have had like a UA221, right? Like a little passive combiner.
Right. Or in the case of a quad, well, there was no quad for the for the PSM 1000, but yes, you'd use a 2-to-1 for systems in the past.
Excellent stuff. Okay, let's have a look at the next one. We have narrowband.
Yeah. So narrowband, kind of normal narrowband where you're not internally combining. This is a kind of what most people are used to, where you have each channel on a dedicated frequency on a dedicated RF output port that you would then put on an 8-port combiner to combine 8-to-1 to 1 antenna.
And in theory, I guess this gives you the most output power per channel, right?
Correct. This mode out of the digital modes offers the most amount of transmitter compensation.
So this is just like a channel to a BNC to a combiner straight through. We're not doing any internal combining. There's no WMAS. It's just hard energy. Okay, let's have a look at the next one. Is narrowband spatial diversity combined?
Yeah. So you could do narrowband with spatial diversity. This reduces your channel count by half, right? So on the quad, it's now a 2-channel device. And then it is internally combining the 2 spatial diversity per channels to just the 2 antennas coming out of A and D for the quad. And then on the dual, it is coming out of A and B, just the 1 frequency with the 2 spatial diversity copies.
Okay, so this isn't WMAS. We're in 200 kilohertz narrowband now, but we're still able to use that spatial diversity secret sauce.
Yes, spatial diversity is a benefit of digital RF.
And it just gives us more RF coverage, more RF stability, a B stage if we want. It's just increasing options by giving us another antenna.
Correct. It's a very flexible device.
Fantastic. Let's have a look at the next one. So this is narrowband spatial diversity.
Right. So this is narrowband spatial diversity. It's not doing any internal antenna combining. So you have 2 frequencies on the quad, with both of them having 2 spatial diversity copies coming, in this case, on the quad A and C for the first frequency and B and D for the second frequency. On the dual, you have that same frequency just coming out of A and B.
Okay, and I guess this gives you another advantage in, because you're not internally combining, you get more RF output power.
Correct.
Fantastic. Our next mode is analog FM combined.
So very similar to narrowband, but this is the analog FM flavor of it, where you have internal antenna combining enabled. And so you're coming out of just the A port on either devices.
So this is like a PSM 1000, but internally combined.
Right.
Analog FM, straight through.
Straight through. So
This is your PSM 1000. So if that's what you want, here it is. Yeah. But you get Dante and you get AES.
yeah, and ShowLink.
And ShowLink.
Yeah.
Awesome. Okay, that is the operational presets. Quite a lot of information in that video. Might be worth going back and rewatching bits, rewatching earlier videos to get a sense of when you might want to use what. But this device can do a whole ton of different things and solve an awful lot of problems that we weren't able to solve before.
Right. The purpose of the operational presets is to kind of customize to your environment and your needs.
So the last thing that we're going to cover is ShowLink. We're going to dive into that in a little bit more detail in the next video. So we hope this has been useful, and we'll see you on that one.